And
I think you have done
hello,
this before.
everybody. Welcome to our Building Microservices with Cassandra and Quarkus workshop. Today, I'm joined by a gaggle. Is it a gaggle? How many is actually in a gaggle? I think gaggle's a good word.
Flock?
A flock?
Murder.
Okay, today I'm joined by a flock of wonderful individuals. Let's see, going from me and moving over to the right, we have Peter Humphrey. Hello, Peter. And then moving over to Erick D'Andrea. Did I say it right this time, Eric? I've been working on that like all week.
Close enough.
Okay,
Close enough.
That's close enough. And finally, Sebastian Estevez.
Hello, folks.
Hello.
Welcome, everyone.
Yeah, welcome. Eric is from Red Hat. We'll give everybody a moment to kind of explain, where they're from and who they are and such. But needless to say, the folks that are over on I should point this way, over on the other side are far more of experts in what we're going to be doing today than I am. So put all of your hard questions to them. That's for Eric and Seb. All the hard questions go to Eric and Seb. Anyway, so with that, why don't we go and just talk quickly about the agenda today, if you could move forward. There we go. Okay, so we're going to cover three things, and one of those is gonna get into live coding. So we're gonna have some live coding, and we're gonna watch Seb type on a keyboard, and hopefully that goes all well. So the first thing is Quarkus. We're gonna talk about Quarkus, what that is, why Quarkus, how does it work. Eric is gonna give us the skinny on all of that information. Then we're gonna move into Astra, right? And so Astra is DataStax's Cassandra as a service in the cloud serverless service, lots of S's in there. And it's honestly, it's pretty wonderful. It gives you a nice mechanism to stand up a Cassandra database within a couple minutes, right? And why are we bringing that here? Because we're going to hook that up to Quarkus. We're going to show you how easy that really is. And then Seb and Eric, they're going to take it, they're going to go into some live coding, and they're going to build up an app from scratch with Quarkus and hook it up into Astra and do the whole thing. Peter, Eric, Seb, anything I missed there that you want to add before we get going?
You covered it.
All
Yeah,
right.
I'm looking forward to the live coding. I mean, I think exceptions will be thrown. Tears will be cried. Things will break, and I'm excited to hopefully try to humiliate Seb as much as possible while he's.
I hope you guys got the buckets I sent you. I did send you tier buckets, so
Thank you. Thank you. We appreciate it.
Yeah, I'm gonna need it. Live coding is ill-advised, but fortunately, I think we got Eric here to yell at me when I do stupid stuff. And
no mechanical keyboard will be harmed in the making of this YouTube live stream.
Yeah,
That's
what
right.
could possibly go wrong live coding in front of hundreds of people? Nothing.
Yeah,
right?
exactly. So, and as usual, before we get started here, as usual, for all of you who are joining us in the chat, ask your questions. Don't be shy, right? That's what we're here for. We're watching the questions that come in, so we'll do our best to try to ensure that we can get things addressed as they come in. But like I said, don't be shy. And Eric, with that, let's do it, man.
All right, next slide. Is my audio okay?
Yeah, and everyone, I believe that we're getting good sound checks, but if you can give us a thumbs up in the chat, let us know that you can hear us and see us okay, and we'll go ahead and get moving. Should be
Awesome.
good.
So let's talk a little bit about Quarkus, supersonic subatomic Java. If we were in a room with all these people here, so I would reach out to the audience and say, raise your hand if you've ever heard of Quarkus, and we'd get some people. And then I'd say, keep your hand raised if you've ever built anything with Quarkus, and you'd probably see, some hands come down. Hopefully, hands stay up. So what we're going to try and do is give you a quick overview, because I know we want to get to some of the live coding stuff, but we definitely want to give you some background as to what we're doing and why it's important. So next slide, please. So if we kind of take a little history lesson, right? This might give away my age a little bit, but Java was invented back when I was in college. So this was about 25 years ago. So, got a bunch of engineers here, so you can do the math. 25 years ago, back in 2020, think about the problems Java was invented to solve. The write once, run anywhere, right? And so if you think about what the JVM did for a long period of time, it was tailored for running these large workloads that ran for days, weeks, months at a time, other than the typical, hey, we need to bounce our app every night because it fixes some problem that we never figured out what the actual problem was. But adding on to that, you've got like millions and millions, tens of millions of developers worldwide that are using the platform, that are building applications, that are helping organizations run their businesses successfully on these with these applications, right? So Java really has become and continues to be the enterprise workhorse. But really, Java was invented in a time where things like the cloud, the cloud solves all problems, right? Where cloud containers, Kubernetes, and whatnot didn't exist. So the days where, hey, I need an application environment where, on my developer workstation, I can run my app, maybe Eclipse, but not Outlook or anything else, right? Because of the huge memory overhead that it took. So thinking about that, the applications would live, for weeks or months, and as a developer, I couldn't do a lot of heavy lifting stuff. So as new development approaches, microservices or whatever it is that you want to call them, ask two people what a microservice is, you get two completely different answers. But Java really continued to remain relevant in the market. There's lots and lots of different microservice frameworks out there based on Java, JVM. You got Spring, you got MicroProfile, DropWizard, Kotlin, Scala, Micronaut, and all that kind of stuff. So the stack of the application itself hasn't really changed too much, but really what's changed is the environment in which we're running these applications. So rather than having an application that's maybe takes minutes to start up, uses 3, 4, 5 gigs of heap space and whatnot, and stays active for a long period of time, we're kind of now in the place where these applications come and go a lot faster, meaning, I'm scaling up, I'm adding more instances of these applications. So startup time really starts to become important, and the write once, run anywhere paradigm of why Java was invented in the first place isn't as important. Yeah, there are plenty of people who run Java applications on non-Linux or Unix-based platforms, but the vast majority of our deployments these days are on Linux. So if we know ahead of time what's going to happen and where these applications are going to be deployed, why do we need to do all the same stuff that the JVM does at runtime? I mean, if you're not familiar with what the JVM does, there's a ton of stuff that happens like in the first 2 seconds of when a JVM starts up. So I'm not a JVM engineer, so I'm not going to bore you with all the details, but just take it on blind faith that there's a ton of stuff that happens there. And so if you're going to run the same instance of the same application over and over and over again, why should you have to do that every single time you start your application? And that's really the foundation of Quarkus, to try and reduce the amount of stuff that we have to do at runtime and shift a lot of that to do it at other points in time rather than at runtime. And that helps to support things like, cloud native microservices, serverless, event-driven applications where, pure performance and startup time is super, super important. All right, next slide.
Yeah, Eric, before you move on to the next slide, I actually have a couple questions that came in, but I did want to ask about the unicorn. I feel like the evolution from, like horses, various horses, and then unicorn, like that's a huge, that's an awesome evolution, honestly. Feels so powerful, right?
Yep. It just seems natural, right? You go from a horse to a unicorn.
Totally. But no, I actually do have some questions that I'm seeing that I think are relevant. Now, you might be addressing these later, so please just tell me if that's the case. I'm seeing a whole set of questions come in. How is Quarkus different from Micronaut? Or is Quarkus a direct alternative for Spring Boot and Micronaut? Right, so I'm seeing a couple of those from different folks. Is that something you're going to address later?
Yeah,
Maybe you can just
let me keep that in the back of my mind and kind of frame it as we move through. And by the end, if you don't have a definitive answer, we can certainly address it.
Got it. Thank you.
And
that's fine.
Eric, I'm also going to pipe some answers into the chat on that one while you're talking.
Awesome. All right. So, kind of going back to what's the underlying runtime. Quarkus was born to, one of the key things is very low memory utilization and smaller footprint. Meaning, if you're in a platform where you're running multiple applications on a host, AKA Kubernetes or something like that, some container runtime platform, you want to be able to run more things given the same underlying, hardware or resources, right? So being able to stuff more things is better for your business because you don't have to buy additional hardware or expand your clusters or whatnot. So really shrinking the amount of footprint, both from CPU, memory, whatnot, and startup time is one of the founding pillars around containers. We say container first. people sometimes will read into that, hey, does that mean I can only run it in containers? Absolutely not. It runs on a JVM just like any other Java application. But what's really, really interesting is this concept of native image. So like I alluded to before, having an application, if we know that your eventual runtime is going to be a container, which is most likely going to be Linux, some flavor of Linux, hopefully RHEL, but I'm a red hatter, I have to say that. But if we know that you're going to do that, well, then we can actually eliminate the JVM from the stack completely. Now, that being said, I'm not going to necessarily go into it, but there's reasons as to when and why you might want to eliminate the JVM and go native, and there's reasons why you don't. We can certainly have a follow-on conversation about that, because there are caveats to that, meaning think about like monitoring or JMX or Java agents and all those kinds of things. Those things aren't going to be available for your application when it's running in native mode. But the native mode does give you a ton of benefit.
So Eric, I think this slide blows some minds, because you're basically telling me I can run my Java app in 12 megs, and it'll start up in 100th of a second. And that's something that I thought, to get that I had to rewrite my app in another language, right?
Yep. Yeah, we'll talk
so
about that. Yep.
Pretty cool stuff.
Yeah. So
Okay.
in some of these metrics and whatnot, we've got everything published in a GitHub repo, with benchmarking and whatnot. But essentially, this time to start up, this isn't necessarily just startup time. It's also time for first request through a system, right?
Nice.
So, just starting up in 4 seconds is great, but if it takes 10 seconds for that first request to go through your app, that's a different story. All right. Awesome. So let's go on to the next one. All right, developer joy. So the one of the other things about Java, or that Java developers have been missing for quite some time, if you're familiar with things like Node.js and whatnot, is, hey, I write some code, I go test it. I write some code, I go test it. What's this compilation and restarting and all that kind of stuff that I have to do. So being able, I grew up in the portal world, in the Java EE world, where you've got these heavyweight containers, or not Docker containers, but application server containers running, where every time you made a change, and you had to recompile and rebuild and redeploy, even on your local machine, that was minutes, if not tens of minutes, depending on which platforms you were using. So trying to optimize the developer experience around saving the time it takes from, hey, I make a change, how do I test it, or how do I see that change running, but not having to learn something, you alluded to learn something new. So a developer doesn't necessarily have to learn a whole new thing to be able to do this. And we'll talk about some of these standards in a minute.
What's that XKCD where I think he's playing with swords and stuff while his code's compiling?
Oh, totally. Yeah.
Someone will drop it in the chat. Yeah, it's pretty funny.
Hey, and real quick, Eric, I think I already know the answer to this, and I think it might be obvious given our conversations, but is Quarkus only for Java, or is it supported in any other languages?
So Quarkus is just for Java. So I'm not going to talk too much about GraalVM and whatnot in this, but essentially GraalVM is aimed for at least for native compilation, is polyglot, so supporting other things outside of Java. With Quarkus, we're just targeting Java, or Java variants like Kotlin and whatnot.
Okay. And Quarkus does depend on GraalVM for the native compilation stuff.
So
on Substrate.
Yes, for Substrate. Yes. So there's a downstream distribution. So GraalVM is an Oracle product, and there's licensing issues that come with that. So for Quarkus on Linux, we've built a downstream distribution called Mandrill, which is completely open source. It's rebased on OpenJDK and only has the parts of GraalVM that are needed to compile Quarkus apps into native applications. It's completely open source and supported by Red Hat for that.
Oh, cool. Okay. I didn't know that. That's awesome.
Yep. And then the generation from native as well. So if you've ever tried to build a native image or use GraalVM kind of on its own, there's just a lot of stuff that you got to do. There's lots of configuration, lots of parameters and whatnot. So being able to run, hey, Maven package, and pass it a flag to say, yeah, build me a native image is kind of cool.
Oh yeah, it's a beast. I was trying to wrap the Cassandra driver in a native image about a year and a half ago maybe, and it was a huge pain with all the GraalVM flags and stuff, and figuring out what packages needed to be brought in and stuff. And today we can just do it. It's wonderful with Quarkus and the extension. We'll talk more about that later.
But do you need to have GraalVM installed in the machine? Adrian asks, or is it just only used to build the native image? As long as we're here, Eric.
Yeah. So to build a native image, you need either GraalVM on the machine, or it can be done in a container. So the Maven plugin, you can point it to like a container image that will actually do the build. So if you have access to Kubernetes or something, you might not have it on your local machine, or your local machine might be locked down by your enterprise security team or IT teams. You can facilitate the build through a container image, and then that can produce your native image for you. But then the GraalVM installation is only needed when you build the native image, not when you actually run it.
Cheers.
Yeah, I will
maybe
say
that's of interest. Like maybe we can throw that. Maybe we can take a stab at that at the end of the hacking session. Maybe we can do it the next webinar. But let's see. Let's see how time treats us.
Yeah, I will say native image compilation is time consuming, and it takes a ton of RAM to do. So you definitely need some hardware in order to do it. I mean, I can do it on my Mac here, but it does, depending on the size of your app, how many libraries and whatnot you're importing, it can take a couple of minutes to actually do the build.
Yeah.
All right. So another thing that still that developers find challenging today is this whole imperative versus reactive. And so, is imperative, is it a programming paradigm? Is it an architecture? Reactive, is it a way to write code? Is it an architecture? Well, the answer, it's really both. And with Quarkus, from a programming paradigm perspective, Quarkus doesn't really care what you want to do. If you want to write reactive code, like in this example here, you want to stream data from Kafka and write it out as a service sent event, using reactive paradigms, great, go for it. If you want to do it imperative, the traditional way of doing, hey, I inject beans and I return things. Great. So like I said, at the end, it doesn't really matter. So that being said, under the covers, Quarkus embraces a fully reactive processing engine based on Vertex. So those who aren't familiar with what Vertex is, or the Eclipse Vertex project, is a really lightweight and super fast framework for building reactive applications, and Quarkus sits on top of that. So it uses a lot of the underpinnings. And so, next slide.
All right.
Yeah, and so we kind of alluded to this earlier. So how do I get this benefit? This all sounds really cool. Do I need to learn Vertex? Or do I need to learn some new stuff? Do I need to learn how to use GraalVM? The answer is really no. It's, at the end of the day, it's all still Java, and it's probably Java that you're already using today. So if you're using things like JAX-RS or Hibernate or integration with Kafka or Flyway or any of these libraries, CDI, dependency injection, Jackson. Great, continue to use them, and Quarkus really tries to not get in your way of using them. It's really there in the background. I think when Seb does some of his live coding, you're going to see, for the most part, there's really not anything in air quotes here, Quarkusy that you're doing here.
Yeah, I think for the most part, it just removes some of the boilerplate.
Right.
I mean, that's kind of how I see it.
So this is kind of like I think maybe a meta question, Eric, in a way, because obviously this is implemented with Java, right? I saw a question come in though, why Java? Why this language? Why provide Quarkus here instead of some of the other languages or something?
Yeah, I mean, if you think about, organizations have huge investment in Java. I think that there was a survey, and I can get the link to it, but it's like $13 billion is the Java server market today, or 2018 or 2019, something. It's huge, and there's millions and millions of developers out there that know Java, use Java, and have worked with Java. So these organizations, that especially these larger organizations, they just can't afford to throw it all away. I mean, they've got a huge investment in it. So why not continue that investment in it?
Yeah.
Yeah, there's also like the kind of the human capital part of it. Like, folks already have Java chops, right? We're talking about like Quarkus and Cassandra here as well, like together. So just from that perspective, you can talk to Cassandra from lots of different programming languages. We got lots of drivers, but by far the DataStax Cassandra Java driver is like the most widely used one. And yeah, it just kind of comes down to what big enterprises use for their code.
Yep.
Okay. Cool. Thank you.
Yep. Yeah. So let's talk just a little bit. And again, I'm not an engineer on the Quarkus team, so I'm sure if somebody asks low level questions, I'm not going to know exactly the answer. But typically, when you look at a Java framework or a Java application in general, you've got this build time versus runtime separation. And traditionally, you build your application or you build your jar, your war, your whatever it is that you're building, then that gets deployed, and the JVM fires up. It finds config files, parses it, looks at class path scanning. Some frameworks are really annotation driven and whatnot. It's going through your class structure, looking for annotations, and doing stuff or loading extra classes, or doing stuff based on what it finds at runtime. And then it kind of builds its model of the world of what the paths through this application look like, and then it starts things. So think about like database connection pools, incoming request thread pools, all that kind of stuff. It's got to start all that management around all that kind of stuff. And that, when I alluded to earlier, the first 2 or 3 seconds that a JVM starts is all the stuff that happens. Then as your application runs, you'll notice your typical Java applications will perform better over time, because over time the JVM is watching what your application is doing and doing just-in-time compilation and reorganizing the bytecode and doing all kinds of stuff to adapt to what your application is doing. We kind of call it warming. We warm the application up a little bit. If you go to the next slide, what we do with Quarkus is it looks very similar, but we try and do as much of that stuff at build time as possible. So
Right.
all that, the class compilation and all that kind of stuff, yeah, we do that. But then all this other stuff that's repetitive and redundant. If you think about containers, say, containers ephemeral, nobody, or hopefully you're not going into a running container and modifying its configuration, because if that container image or instance goes away, the next one that starts up isn't going to have whatever changes you made, right? So if we think about, hey, if we know we're going to run these in containers, if I want to change or alter the functionality of an application, I should do it in a way that signifies the change, meaning like make a code check-in, go through my CI/CD pipeline, produce a new version of the image that represents whatever that change in behavior was, right? And once I'm there, then we've been able to do the majority of that stuff ahead of time at build time. And then the runtime becomes super, super fast. So there's actually bytecode that's generated and inserted at build time that's kind of stored off as part of the artifact that's built between the build and the runtime. And then you can still run it on the JVM. I mean, there are plenty of reasons. Just because you have the capability to do native image doesn't mean native image is the best solution for all problems, right? It's a solution for some problems that we'll talk about in a minute, but it's running a Quarkus application on the JVM is still going to outperform a lot of the other frameworks and whatnot that are out there today. Next one. And then just a couple use cases to wrap up. Net new microservices, monolith to microservices, serverless, event-driven, reactive, IoT. So a framework for being able to build your containerized microservices, the unification of both the imperative and reacting programming styles, even within the same class. I mentioned Quarkus doesn't really care which one you do and how you do it. Even within the same JAX-RS class, I can have a reactive endpoint and an imperative endpoint. Quarkus doesn't really care, right? And we'll see that, I think, in a little bit of the live coding. It's a great tool for modernizing monolithic applications, breaking them into smaller, more loosely coupled microservices. Whether you're going to run it on a traditional a JVM or a server or whatnot, being able to eliminate some of those long boot up times. Serverless, Quarkus makes a really good use case for running serverless applications. So anybody who's done like Azure Function or AWS Lambda or whatnot, I think there was a study that came out that was like 6% of people actually use Java to build serverless applications on these cloud platforms. Well, with Quarkus, why not? I can write the application once and truly run it anywhere, especially that these providers allow you to run container images as serverless applications. And by serverless, I don't necessarily mean functions as a service. I mean like full-blown applications that scale down to 0 and go away when they're not being used. Functions as a service is definitely something that falls into this realm that you can do. Quarkus has this thing called Funky, which is its functions as a service implementation. But there's an extensive library of stuff, and again in air quotes here, stuff to choose from to be able to use. And we'll see some of that in the live coding here.
Eric, one last one on use cases while we're here. Someone asking if we could use Quarkus for JavaScript or Node. I'm imagining yes, JavaScript as a front end, full page, single page app, but probably not Node, I'm guessing.
So Quarkus is a Java framework. So you can hook up, through HTTP or whatever, you can communicate with whatever types of applications you want in your ecosystem. But building a Quarkus application means I'm building a Java application.
Yeah, I mean, we'll do that hooking up today. We'll get into like some front end stuff, but yeah, like Quarkus is a Java backend thing. But yeah, like what I take away from this, and it's all really cool stuff. Like some of these like cold start problems, or all these things about Java that makes it sound like it's not going to play well in a modern kind of Kubernetes container world, kind of go away, and so I don't have to like go learn Golang necessarily, right? Like if I've got a bunch of Java chops and skills and applications, so that's super exciting. And then there's this concept of serverless that I think we're going to dive into as well, as we talk about Cassandra and Astra, and kind of I've been thinking about that in like there's a thing that Forrest Brazel said, and I don't know if I'm pronouncing his name right, but something that he says is when you have the serverless mindset, you want to build more and own less. You want to have less responsibility for like running and maintaining systems, and just be able to develop and create more solutions. And so like when we're talking about serverless, that means the ability to take advantage of third-party services like a database as a service. It also means running things in potentially like in containers and Kubernetes, as well as the function as a service, right? Not limited to like Eric was saying. Okay, so yeah, I can transition a little bit from that to start to talk about Astra. I think the general flow is going to be like just to make sure that everybody's kind of up to speed on what we're talking about. A couple of high-level slides on what Cassandra is and what it does, and why you would be interested in it and pick it. Then a little bit about what Astra is, which is, as David mentioned, our serverless Cassandra on the cloud. And then we'll get into kind of how this goes really nicely with Quarkus and how we can use Cassandra and Quarkus together. A little bit about the extension that we built last year. So so Apache Cassandra is a open source Apache license and also Apache Foundation project. It's a distributed database, and arguably it's the most scalable distributed database out there. And so it gets picked to run some of the biggest, most throughput intensive transactional apps that you might have on your phone. And so that includes things like a lot of the things on Apple iCloud, and a good chunk of Spotify and Netflix and all these other big companies and big applications that really need kind of the throughput, the availability, the geographic distribution, and the performance that Cassandra gives you, as well as kind of the open source nature. So just a little bit about how Cassandra works, and I think we'll do a little bit of data modeling in the live coding part. So I figured we'd do a little bit of that, a little bit of conversation on that. When you've got a Cassandra cluster, it's lots of database servers, right? Lots of computers, and they all kind of work together, hanging onto your data and being able to serve requests. And so when you have a big table, you're able to partition that table based on fields that you control as a developer. And so when you design a Cassandra table, in this case, you pick a partition key, which is a country. And so that means that the data will be spread out based on countries across your, let's say you have a 1,000 node cluster, right? And so actually country is not a great key, because depending on your app, you might have, a lot of your workload in a couple of countries. And so your partitioning might be pretty skewed. But just to give an example of how that would work out, a set of your nodes might be responsible for the records that happen in the US, and another set of nodes may be responsible for the records that happen in France, et cetera. So there's partitioning there, and we were able to split the data up. Now, that doesn't mean that you have to kind of know what Cassandra node to ask a question to. Any Cassandra node can, take any put or get, and then it does kind of coordinating behind the scenes to actually either persist or fetch the data that you want. So another key thing about Cassandra is that it's got geographic distribution and replication built in, and so there's a concept of a data center in Cassandra, which in today's world we map to, most often, either your physical on-premises data centers or the region that you're operating in a cloud. And so you can have single clusters that span geographic regions, that span data centers, that span clouds, in a single cluster, and then you keep n replicas of your data, across all of those data centers. And so that lets you do things like get geolocal latencies for your application. So if your app is running in the east or the west of the U.S., they would talk to the database data center in that local data center and get geolocal latencies, but still replicate that data everywhere in case you need it, in case you need to reach it from the other side of the world. So that's a little bit on data everywhere. And then again, to talk about use cases, kind of why do people use and pick Cassandra? I think historically, folks pick Cassandra when they have kind of very intense scalability, availability, distribution requirements. And so that means, very large applications. And, if you're deploying your own Cassandra cluster, there's, let's say, like a cost of entry there of like standing up a cluster, learning how to run it, learning how to operate it, and like paying for the physical infrastructure to run that cluster in, that is probably not insignificant, right? And so one of the things that Astra is doing, and especially our serverless version of Astra that was GA'd, I think, last month, is it brings that kind of barrier of entry for using Cassandra pretty much down to zero, right? So DataStax Astra is our Cassandra on the cloud, and it's serverless. Basically, we give any user that creates a database $25 free every month. So those $25 kind of reset at the end of the month. And that's equivalent for, that lets you do like, tens of millions of ops in the month, or hold on to, gigabytes of data, et cetera. And then, we'll reset that at the end of the month. And, if you go above that, then you can put in your credit card and, pay for your usage, and you get billed based on your throughput, basically the operations that you do against the database. Like, so you'll get billed per million ops, and you'll get billed for like amount of data actually stored in the system.
So Seb, $25 a month. I mean, help me get my head around that. Like, what does that mean?
Yeah, so I think if you look at the pricing, so there's different pricing for reads and writes, but like a million writes on like one of the Google regions is about $1. So let's say that that would be 25 million writes. I think reads are like a third of that price, something like that. You can check it on the website to be exact, but that means that you could do 75 million writes in the month for free. It's hefty. Like, we could all run our side projects on this thing for free. We could probably prototype stuff, and even do development for like significant apps for free. And then, only if you hit virality are you gonna like, pay for it. And it's actually a nice deal.
I think it was. I think on the North American GCP data center, we benchmarked it at like 30 million writes, 5 million reads, and 40 gig a month.
For free,
something like that. Yeah,
for free within the $25 credit. Yeah,
that's what that $25 means. Yeah, so
that's right.
Cool. Just trying to make that a little
so a couple other things on this slide that I skipped. There's powerful APIs, which I know Peter wants me to talk about. So Astra not only supports Cassandra query language, which is the thing that we're going to use today, but it also supports different additional APIs. So one of them is a JSON Document API that basically is a REST interface directly against your database, and so you can just persist your JSON objects directly to the database, kind of without a query language. It also supports GraphQL endpoints, as well as table-based RESTful endpoints, and you can leverage those directly from your app without like using a driver or anything like that. So that's an option in addition to CQL for folks that aren't already familiar with and using Cassandra, but want to take advantage of some of these capabilities. And then we also run on the multiple clouds, and it's designed to be cloud native. And what we mean by that, especially in the serverless mode is like just the storage and the compute in Cassandra are actually separated under the hood. And so what that gives you is the capability to, it gives us the capability of auto scaling for you automatically. And so, you don't have to think at all about kind of how much throughput you need to purchase in advance, or how many nodes you need to be running, or all kind of the complexities of running a database, right? It's all kind of auto scale under the hood for you. So that's a little bit about Astra. I think I already covered this stuff, so I'm going to go ahead and skip it. I want to talk very briefly about migrations. So if you are running Cassandra yourself on premises and you want to move it to Astra, we have some very nice tooling to do that, including the ability to move the data over, move your applications over without any downtime, right? So definitely reach out to us if that's of interest. And then I'm going to move on a little bit to talk about Quarkus and Cassandra together. So I want to say about a year and a half ago, something like that, I'd been poking around using Quarkus and Cassandra together, and our drivers team got interested in that, and they built a really cool extension. So the way you guys will see this as we kind of get into the live coding, but the way Quarkus kind of is laid out is it works based on extensions. And so all the different Java libraries that you're used to using, a lot of them have extensions in Quarkus, and you can go pick those out and grab them and throw them in your palm, and you're ready to roll. So the features of our Quarkus Cassandra extension include native compilation, which we talked a bunch about already with Eric, the Cassandra driver session support. So if you've used the Cassandra DataStax driver, there's some configuration and some work, some boilerplate that you do to establish to even get a cluster object going. All that stuff is kind of done for you based on a native Quarkus configuration. There's also support for the object mapper. So for those of you that are using relational and use things like Hibernate, those are ORMs. In the Cassandra world, because we're not a relational database, we don't do ORMs, we just do OMs. So the DataStax driver has an object mapper, and there's support for that here in the Quarkus extension, the OM. Yeah, it's very zen. We do support mutiny types, which is, if you want to get into that, some of that reactive style coding that Eric was talking about, that's supported, and we have some nice docs on how to do that. I think we're going to stay away from the mutiny reactive stuff on the demo today, but there's plenty of good documentation for that if folks are interested. And also there's also support for DataStax Astra on the cloud. So here's the configuration and what it looks like. Quarkus has an application.properties file where you throw in dot separated config, and and dot separated config. And so these are the options some of the options that are there for the Cassandra extension. One of them being so that's the first one at the top is Secure Connect bundle, and we'll talk a little bit more about that when we go spin up a database. But that's basically a zip file that the Astra service provides to you as a user to enable you to connect to the service, and that includes certificates and other security things, as well as like a fully qualified domain that you actually use to connect. It all goes into a zip file to kind of make connecting easy, and so that zip file is supported by the extension. We also have, you can also specify key space, you can specify credentials, username, password, and some other driver level config like timeout and consistency levels. And then at the bottom, we'll talk a little bit more about this with Eric. We have metrics and health, which are basically integrations with other Quarkus extensions that give you things like metrics and health, which are going to be useful to you if you are looking to like observe your app with Prometheus or something like that. Also useful to you. The health is useful to you if you're running in Kubernetes, and Kubernetes needs like a health and aliveness endpoint, right? So those kind of get built for you automatically, and and so it'll show us up and healthy and live once Cassandra is connected from the driver. So just a little bit of config gets you a whole bunch of value and stuff that you used to have to code. So this single line is what it looks like to get to connect to Cassandra once you have the config, right? You literally just inject a Quarkus SQL session, give it a name, and from your class you are able to actually start executing queries right away. It's pretty slick. This is what the object mapper support looks like. So you can create DAOs and take advantage of the object mapping support in the driver. And this is what the Mutiny like reactive style of interactions looks like if that's kind of your style of choice, right? So you can subscribe and publish stuff and do streaming. So great. Last bit, I mentioned that we have additional developer endpoints that are in Astra. Those are like the JSON Document API, the GraphQL. There's also a couple SDKs. The JavaScript SDK is already available. There's a Java SDK coming soon. So if you needed to use, let's say, the JSON Document API from a Quarkus app, then you would use the Quarkus REST client extension instead of the Cassandra one. And there's some samples of what those APIs actually look like on the right, but it's nice. It lets you just take a JSON blob and post it to a collection of the database, right? Like you're using a document DB. Awesome. So yeah, so that's the bit around what Cassandra is, what Astra is, what the Cassandra Quarkus extension is all about. Are there any questions before we kind of jump into the scary part of this, which is where I try to code and ideally not mess up?
I think Eric and Peter have been all over them. Unless there's something between you guys that you want to address that you see in the chats.
Yeah, I mean, I think the theme I see in the chat, if I can narrow, because it's like scrolling faster than I can keep track of it.
There's a lot of good. By the way, we love your questions in the conversation, so by all means, keep that going.
Rock and roll.
Yeah.
So I will say the overall theme I'm seeing is like comparing it to things like Spring and whatnot. Right. And I'm not here to throw anybody under the bus or anything like that. That's certainly not what we're trying to do here. But someone had asked about like, how do I know, like, I'm a Spring shop? How do I know about migrating my app? I throw a couple links in the chat there. There is a compatibility layer, so you can continue to use some Spring APIs in Quarkus. That being said, it's not meant to implement the entire Spring framework or re-implement the entire Spring framework on Quarkus. It's more of a, hey, I'm familiar with Spring. Can I get started and can I learn as I try to tinker and play with it and still get the benefit of it? And so the answer to that is yes, but it's not meant to be a whole.
And Eric, I think it might be interesting just to acknowledge one last thing, which is like, Spring Boot generally defaults to like either Tomcat or Netty, depending on whether you're going the reactive or non-reactive direction. I know there are other options, it used to be at least for things like Undertow, et cetera. You talk, a lot of questions in the chat are about the programming model. And I think one of the things that really intrigued me about what I learned talking to you was the difference in the runtime, that Quarkus and how you approach the unified reactive.
Yeah, so at the underpinning, Quarkus is based on a reactive engine that reuses what's already available through Vertex. So the whole reactive capability that Vertex provides, it's somewhat hidden from you in Quarkus. So you don't really necessarily have to. I mean, you certainly can if you're familiar with Vertex and you want to use some of the Vertex stuff in Quarkus. by all means, go for it. But it really tries to hide that away from you. That being said, a lot of the specifications that are out there, like JAX-RS or GPA, are just that. They're specifications, right? Most of the time. I mean, I know Jersey I saw in the chat was mentioned like for as a JAX-RS implementation. There are other implementations of a lot of these things, especially from MicroProfile. And so Quarkus brings in a lot of these other implementations of stuff. So for like JAX-RS, you've got REST Easy. As the implementation for JAX-RS, and under the covers, all that bridging between reactive, the IO threads, someone who's familiar with like Spring Webflux as an example has to like be absolutely certain that what they're doing in their code doesn't do blocking work, right? Because you're on you have to be super, super careful about the IO thread. Quarkus just kind of handles that for you. And there's a couple different ways, and we'll talk about it when I was kind of saving that for when Seb starts to go into his
Sure. I didn't mean to fast forward you. Yeah, didn't mean to fast forward you. I just thought that it's good to kind of separate the conversations of programming model versus runtime, because there are significant differences in both. But I think to your point, there's a lot of like moral equivalent programming, programming model and API structures on both sides. But there's a lot of differences in the runtime. Cool. Thanks, Eric.
Awesome. David, swag reminder.
Oh, yeah, that's right. So, as a matter of fact, I was just responding to Coder over in Discord about that very thing. So I guess I'll just say it in voice instead of trying to type it out. We actually have a couple things that we're going to give away for all of you coming with us today. But you gotta stay with us. You have to go through the tiers of watching Seb code live. But then at the end, we will drop a link for you to get some Red Hat swag. Now, Eric,
they're going to be tears of joy, right?
Tears of joy. So you get to replace your
so.
tears, the tears from Seb, and replace them with tears of joy. So we will drop a link for that at the end for you to get some swag there. Now, that swag is limited, right? And we have enough folks on here. If for those of you who want to get it, when we drop it, do it quick, right? Now, we're going to also have another giveaway for you, though. We're going to drop a form to get you one of two things. And one could be a free voucher for 2 attempts at a Cassandra certification. Those are $145 a piece normally. The other option is to get yourself $300 in Astra credit. And again, we'll drop that at the end. So there's swag and there's the other giveaways. And with that, I think we can start into our tier journey.
So, David, you're going to drop the database at the end?
Say again?
You're going to drop the database at the end?
Yeah. Nice, Peter.
That was pretty cringy, man. Right on.
I think I'm gonna use that from now on. Let's drop the database. Yeah.
Okay.
It's very good.
Nice drop. All right, so I'm going to summarize what I'm going to do with this live coding, and there will be a lot of help from Eric and the team as I mess up. But one, we want to deploy a database in Astra. 2, we're going to create from scratch a Quarkus application. Then 3, there's a little sample app that's relatively well known. It's called To-Do MVC. Basically what that thing is like a very simple to-do list application. I think the one we picked has React on the front and no backend. And we're just going to kind of reverse engineer the backend, fill in the endpoints using Quarkus and Cassandra to hopefully at the end of the session actually make it run. And then finally we'll get into the swag stuff. Right on. So I'll start with deploying the Cassandra database. So if I go to astra.datastax.com and I sign in, you can either create a user with your email and password, or you can use social logins. You will see this screen, which is basically a dashboard. And I have 3 databases that I've deployed, and I'm going to go ahead and deploy a 4th one. Just to show you how it works. So it's really pretty simple stuff. I think there's 3 things I have to do. I have to give my database a name, Quarkus and Cassandra, and I'm going to give my key space a name, and we're going to call it to do. And then I have to pick where I want to deploy this database. So today, Astra Serverless has options for deployment in multiple Google and Amazon regions. We do have Azure coming soon. And so I'm just going to pick AWS US East. And that's it. So I create my database, and you can see that it's coming up here, status pending. It usually takes a couple minutes for that database to come up. And so in the meantime, I'll switch over to one that we've used in the past. And so you can see that I've performed some operations against this database. I've written 5.9 million writes against it, done a lot less reading. I've got a few hundred megs in there, and so far that this database has cost me $5.97 out of my free 25 gigs for the month, or $25 for the month. Yeah, and you can see like some other things like what provider I'm running on, and the fact that I've got a couple of key spaces. So one thing I can do is jump into my CQL console, and let's see if I've got this table already created or not. I think I might not, and I want to drop it before we do anything else. So I'm going to describe my key spaces. What's a key space? I actually should have described what that is. A key space is just a grouping of tables in Cassandra.
And Ion, our friend Ion in YouTube earlier said you usually drop the database in prod when your morning is very boring. We're not going to drop one right now, but
I'm going to drop a
you know, if you like doing that for your mornings, that's great, man. You know,
It's a good way to test your monitoring, right, and see who's paying attention.
Yeah, right.
Yeah, or your user base list.
Have you guys seen that write a stat developer story in 3 words meme going around? I think one of the top responses was like drop table and like 2 million rows updated. It's like, oh no.
I think we've all had a moment where we've done something terrible to a database. I one time dropped. I was on the wrong database. I never made this mistake ever again. I thought I was on my dev database. I was on prod. And I dropped 6 months worth of device data from thousands of our servers and network devices. That was a oops moment. And that was with Oracle. And that was using RMAN and stuff, if anyone's ever done that. So that's going back a little bit. Anyway.
Yeah.
If you had one of those stories, please give me a tier in the chat.
100% uptime with, or 100% uptime with Cassandra, but user error is still user error.
Yeah, exactly.
What, the cloud doesn't solve that problem for you?
Yeah.
Yeah.
Unicorn slide.
So I think we've got a database going, and I'm going to switch over and talk about Quarkus a bit. So this is one of the parts where one of the multiple parts of today where Eric's going to help me not mess stuff up. But if you go to code.quarkus.io, then this is a very handy kind of web page to get your Quarkus app started. This isn't the only way to do this. You can do this on your terminal, and you can also do this using your favorite IDE's Quarkus extension. But let's start with the web. It's actually very nice, and so you can see here that it's basically a list of extensions that I may or may not be interested in. And for today's application, we need something that lets us do REST endpoints. So we're going to pick REST EC Jackson. And let's see, what else do I want?
Yeah, so maybe it's a good time just to talk like quickly what an extension actually is. So
yeah, great.
So we talked about, Quarkus doing a whole lot of stuff at build time, and in a whole lot of stuff, I'm going to put in air quotes here, right? Extensions are the way Quarkus accomplishes that. So Quarkus has extensions that the Quarkus team themselves builds, and there's also extensions that are built by others in the community, a la why we're here today. So whenever it is that you're looking to do something like build a JAX-RS application or something, you're going to want to go find the extensions. And the vast majority of what an extension does is that build time optimization to make it super, super fast, right? The folks building the extensions, there's a whole set of best practices, guides, and things that they have to adhere to, but that's part of building the extension. So what we'll do here, and I'm going to shame on Seb for a second. We're going to Yeah, so we should actually use the REST Easy reactive extension, and I'll explain why. So REST Easy being the JAX-RS implementation, you find REST Easy like if you're using like Wildfly or JBoss EAP or any of these things as the official JAX-RS implementation. REST Easy reactive, and it says experimental there. That's just because it's new. That doesn't change the way you actually build your application. So like, we could get through this whole demo today and then go back and swap the dependency, and Seb wouldn't have to change a line of code. What the difference between REST Easy Reactive and the what we call REST Easy Classic is pure performance. So REST Easy Reactive is much tighter integrated with the whole event loop thing. So even if you're going to do blocking work, which Seb is going to do here, it's still a whole lot faster from benchmarking perspective if you're going to do blocking work using REST Easy Reactive versus doing blocking work in REST Easy Classic, even though your code is exactly the same.
Yeah, because Eric's not the guy doing the live coding, so he's okay with using experimental.
Yeah, that's right. What could possibly go wrong, right?
But yeah, no. So we'll pick yours, and we'll also pick the fighter jet. The fighter jet one. Actually, fighter jet means that there's some sample code embedded in this extension.
Yep.
So that's all that means. So I got myself the Cassandra extension. Obviously, we need that. I got myself REST Easy Reactive and also Jackson for the serialization to serialization. we're going to need something for health, right? Small right health. And we're going to need something for metrics.
Oh, we're not really going to need them. These are kind of like things that,
optional.
if I build my application, running it locally, I probably don't need it. But once I go to put it somewhere, I need some of this stuff.
So we're showing off a little bit at this point. All right, so yeah, because we're going to get kind of health and metrics almost for free. So that'll be nice.
Maybe we'll get it for free, actually. Yeah, not almost. We will.
Yeah, we will. Even like, because not only do we have the health and metrics extensions, but also like the integration between them and the Cassandra extension. All right, cool. So yeah, this gives us, and I should also like rename stuff. So we're going to call this org, I don't know. Com DataStax demo. The artifact is going to be called Quarkus demo. We're going to use Maven because I like Maven. I think Eric likes Gradle, but he's going to forgive me.
We're not doing the coding, right?
That's right. We're going to keep the sample code. And then I can just click this button. So cool thing, you can push this right to GitHub, which is interesting. So you can get like all this stuff stubbed out to a brand new GitHub repo, which is pretty slick. You can share this with your friends. Drop it on Instagram if you want, or download it as a zip file, which is what we're going to do today. And so you can see in my downloads directory, I've got a Quarkus.demo or Quarkus-demo zip file. And then this very handy instruction set tells me you can run Maven W compile and it will just work. So let's give that a try. I'm going to come down to my terminal. You can see that I'm already, you guys are seeing my Slack. So I'm already at my downloads directory. And what did we say this thing was called? Quarkus demo. So I'm going to go ahead and make it. I got a directory called demo. And I'm going to unzip my Quarkus demo, not that one, that we just downloaded, if I can spell. Right here. And you can see that I've got a Quarkus demo directory now. And if I show tree on it, this is basically what we downloaded, right? So there's a Maven W command that's kind of a nice wrapper around Maven. Then there's my POM, which with my dependencies already baked in. And you can see, like, as you might expect in a traditional Java program, there's a source, main, test, and resources. It does have tests because we're going to attempt to look like real programmers and use unit tests.
Yeah, and I'll notice too, it generates a whole bunch of Docker files for you. So, we talked about different ways of running the app, whether it's on the JVM or native image. There's already kind of pre-canned Docker files there for you that it generates. Right on.
Yeah, beautiful. Cool. Okay, so yeah, we're cloud native here. We're ready to go on. We're ready to drop this thing on Kubernetes or something. All right, so we got ourselves a sample project started, and I'm gonna go ahead and pull that up in my IDE. I'm an IDEA user. So let's see if IDEA comes up.
Cedric's like, a tree on a Mac? He's like, oh, he's on Linux. Oh.
Oh.
That's funny.
Yeah. Okay, so I'm going to pull open new project from existing sources is what I want. And this is in our downloads directory, and it's called Quarkus demo. We ran through this yesterday with code with Quarkus, so that's the wrong one. Quarkus demo is the one we just downloaded. It's got nothing in it. This is a Maven project. We can tell IDEA that, and we'll open it up in this very window. And so Maven's going to start downloading the internet for us here in terms of indexing. But if I pull up my terminal, I'll go ahead and follow the nice instructions also in this README. They were also the same, the same command that it told me to do on the web.
Oh, hey Seb, could you zoom in your screens a little bit, make it a little bigger?
Yeah, absolutely. Bear with me. Actually, IDEA's hanging a little bit here while it downloads the internet. So
Oh, that's right. You are downloading. So we're downloading the internet, though, not the whole world, correct? So
What's
depends
bigger?
if you're using Maven or npm.
Wait,
Which one?
Are you using npm? Or,
Yeah. I think Maven downloads the internet. npm downloads the world. I think that's what it was.
Right. There you go.
Okay. I want to make sure I had that right.
Compile. Quarkus dev.
You probably want to make it a little bigger too, Seb.
Yeah, absolutely. Increase font. See if I can get that to work.
There's a helpful comment from the audience about IntelliJ's presentation mode for future reference.
Yeah, we can get into that maybe in a second when I start
good
coding.
point, Ian.
Do you guys use Zen mode? Does anybody use Zen mode? I think maybe that's the one that we'll try. I don't know how to spell increase.
Just go into your preferences and change the font size.
Change the font size. With the mouse wheel, should I try that? Let's try it. Oh yeah, check it out. Lovely. All right, so Maven did download some stuff, my dependencies, and it started out the Quarkus application. And so you can see that it's telling me that I have that the process is listening on 8080 here on my local host. I'm going to open that up in a web browser. And so my brand new cloud native application is ready. It's pretty slick. And it's cloud native because it says so on the main HTML here.
Oh, it does say right there. It does, yeah.
Yeah, it does. So it's cloud native, guys. Ready to roll.
Our work is done. Our work here is done, right? We're cloud native.
So Eric showed me yesterday this super sweet little trick that if you go to /q/dev on your Quarkus UI.
Let's make it bigger. Make it bigger, Seb. That screen. There you go.
Ah, too big. Too big.
Not that big.
There you go. Okay. So it's got information about all the extensions that I brought in. And so if I didn't know how to use the Apache Cassandra extension, for example, it's got a link right to the docs, right? That's pretty cool. And similarly, it's telling me some other things like we turned on monitoring and health. So if I pull up the health section, Eric, you were saying I should click on which one of these?
Yeah, pick one.
I'll open up the UI because it's human readable, and then we'll show what the regular health one looks like for like readiness and liveness if I'm like Kubernetes or something programmatic. So the UI is going to load the probes, and it should tell me that my app is alive, hopefully. Oh, maybe I don't have any because I haven't done anything. Yeah. Okay, perfect. So
if you go to the other one, you should just get a JSON that says okay.
Yeah, so actually, yeah, you're right. So the health UI may come back and give me stuff once I start up my Cassandra session.
Yep. Hey, real quick, Eric and Seb, I saw a question, and I just don't know the answer to this one here. Can they use Eclipse with this as well? I don't see why you wouldn't be able to use any of the IDs, right?
Okay. Yeah, there's plugin there. Yeah, there's a plugin for Eclipse VS Code.
There you go.
What's going on?
I mean, you can code in Quarkus from Vim, guys. Like the plugin is nice, and I'll show you guys what the plugin does. One, it does like similar. Oh, why is this blowing up? Oh, okay, so health is cool. The plugins is cool because it gives you like a similar flow to start on your application the same way we did here on the web. It also is nice for when you're messing with your application properties. It's got like autocomplete here. So we'll probably use that in a second. But yeah, like you can code in Quarkus from Vim and just run Maven W Quarkus dev and go if that's your preference, right? There isn't like a strong opinionated you must use this IDE thing. Cool. So this sample app came with some sample code, and you can see that it stubbed out a class here called reactive greeting resource, which is an endpoint at /hello rest easy reactive, and it says hello. So let's actually test that. If I copy this and bring it up in my localhost 8080, there you go. So it says hello, and that's really great. Now we're going to get into some of the cool hot code reloading stuff that Eric was alluding to. like if I wanted to change this to hello Cassandra users, and I save that file, and I refresh my browser, we should get hello Cassandra users right in my web browser. That's kind of slick. And you can see I didn't do any like recompiling or anything like that. So I guess at this point is maybe when we've done the part where we deployed a database. We've done the part where we created a brand new Quarkus app. Now we want to get into this sample application to-do list thing. So maybe what I'll start with is I'll show what the final app should look like. So if you guys type into your web browsers to-do NVC, here we go. You can see that like this is a cool example that folks have implemented in all sorts of different front-end frameworks, and there's even back-end frameworks in there too. So I'm just going to pick a random one. I'll pick the Vue.js one, which is something I've been using lately. And so this is the app, and it lets you type in to-do. So we were talking yesterday that Eric needs a vacation. So get Eric a vacation is going to be a to-do. And so you can see our to-do shows up. Also,
yeah, the capital E was super important, right?
Purchase a puppy. That's right. And then I can like check them off as soon as I do them. Try to do list. I can check them off. That's very satisfying. And I can also delete them. So this is basically like a very simple to-do CRUD. And you can start to kind of imagine if you start thinking about the database or whatever stateful layer is backing this, you need something that holds on to your to-do list. I think there's a way to share like a list with somebody else and they can add stuff to it, like from different computers. And then you need to be able to hang on to the list items themselves and actually like create them, update them, delete them. You need to hold the name of it probably somewhere. I think we've been calling that title. You need to be able to create new ones. You need to be able to complete them. You need to be able to delete them. So pretty simple kind of CRUD. And so we're going to go ahead and bring into our sample app just the front end version of this app with none of the back end wiring. And then like we'll see it error out whenever it tries to call a back end component. And then we'll go in and, without restarting our process, we'll just add code. And hopefully we'll get this thing to persist to-do items to Cassandra. That's the goal. So the first thing I want to do is I want to serve up some static HTML and JavaScript. And I want to do that. The way to do that is by sticking stuff inside meta-inf resources. It's basically all it is. This index HTML file is the pretty we are cloud native ready thing that we saw in the beginning. So I'm going to go save that as something else. The source, resources, meta, resources. So it's index. We're going to call that cloud native in the HTML. And then we're going to go ahead and copy from, I have another app here somewhere in my desktop. Quarkus demo. By the way, maybe this is a good time, David, if you want to drop the link to the repo in the chat. So we've got like the answers to this in a repo called Quarkus-Cassandra demos. And so if you guys want to run through this at home, like there'll be two options. One, you can pull the main branch, and that's got like the solution with all the code and the answers. Or you can pull there's another branch in that repo called puzzle. And if you pull the puzzle branch, it starts you right here where we're at right now, or actually in a second when I've moved the HTML stuff over. And so then you can do your own, reverse engineer hacking like we're doing today in the session. So source main.
You get to puzzle it out.
Resources.
Is that what you meant by the branch?
Yeah. You can it's a puzzle. All right, so I'm going to grab all this stuff from here, and we're going to stick it in my source main resources meta.
Don't forget to copy recursively.
Copy recursively. I messed that up yesterday. Thank you, Eric. You guys will quickly gather that Eric's a much better programmer than I, and much more detail-oriented, which is like half the battle. Mm-hmm. He's like, yep, I am. Eric's not shy.
There's nothing left for me to say. You said it all, right?
That's right. That's right. Check it out. We've got a little front end app. Right? So all I did was copy the static HTML in there. Quarkus was smart enough to pull it in. And if I pull in my web console here, you can see that when I refresh this, I'm going to get some errors. It tried to, let's see, it tried to do a GET request against localhost API to do. And then this ID, which I think is the UUID like representation of a to-do list itself, not a to-do item, but a to-do list. And then it's trying to pull all the items for that list, right? Obviously, that this endpoint does not exist, so I get a 404. And so we're going to go and figure out if we can actually create that. There's a couple of things I have to do first, but we'll get into it. So first, let's test
Do you
out
want to
this.
connect to? Do you want to show the connect to Cassandra first before we
Yeah,
start building endpoints?
Yeah, we got to connect to Cassandra. We got to let's just start by testing the hot reloading capabilities by doing some refactoring of class names. What do you think?
Go for it.
That sounds
You're
fun.
living on the
All right.
edge.
Is it
Living on the
wrong
edge.
that I just had a Foreigner song pop into my head with hot reloading? Hot reloading, check it and see. Come on. I mean, that just dated me as well. And sorry for those of you I just brought back to the. God, was that the 70s or 80s?
That was the 80s.
It was
yeah.
the 80s. Woo! Okay, that's
Yeah, right on.
That's right. Hey, when I was talking, I was saying Java was born 25 years ago, and that I was in college. So you're an engineer. Do the math.
It is funny. The 80s are now considered like oldies on the station. So what does that say?
Yeah, and you were probably one of the ones in the back seat of your parents' car saying, "Oh, why you have to listen to the oldie stuff, right?"
Oh yeah.
Cool.
So I'm renaming this to API/health. So not only did we change the endpoint paths, but we also refactored the class name and everything. So that should be a good test of this hot reloading stuff. If I say /API/ what did we say? Hello?
Thought you said health.
Health? Why did I say
Look, it
health?
told you right there that, hey, did you mean health?
Oh, that's really slick.
That is actually
it's
good.
like,
Yeah.
hey, you typed something, but maybe you meant this.
Yeah, and I actually meant hello all along, but yeah, super helpful. So this developer experience is really nice, right? Yeah, it's much nicer than when you're cobbling together all the different. Yeah. Okay, so API hello. Worked with all of my refactoring with no restarting of the process, which is super slick. So yeah, now we want to connect to Cassandra, and to do that, there's a couple of things that need to happen. First, I'm going to go back to my DataStax Astra UI, and I'm going to show you guys a couple of things. One is in settings, I can generate some credentials. The other is going to be under connect. I can download that bundle zip file thing I was talking about. Let's start with the bundle. So if I go into connect and I go to Java, I can download this bundle. Yeah, it's fine, I think. So now it's sitting in my downloads directory, and it's called secure connect serverless db.zip. And then I'll go generate credentials later. So if we go to the slide deck that we showed earlier today, we actually showed you guys exactly how to do this. So I'm just going to pull it right from the slide deck. You guys can do this at home as well. We'll probably publish this slide deck somewhere.
Oh yeah, I already published the slide deck to the repo. So it is in the root of the repo.
All right. Okay, so then these are the config things, and the ones that I care about for right now is just 3 of these. We're going to grab, I don't need a key space. I don't care about that. We need the path to the connect bundle, which is going to be, let's see where I put it.
You want those other ones too, like the health and the metrics too, right?
Oh yeah, we'll want health and metrics. That's true. I'll go grab those in a sec. No. Yeah, because we want to show off the health stuff that folks are thinking that it didn't work. It's because we hadn't finished. So secure connect serverless DB, we called it. .zip. Yeah. So this is my path to that. I'm gonna grab it. Geez, come on. and we said it was called Secure Connect Serverless DB.zip. Thanks for bearing with me, folks. All right, so that's the path to the bundle. Then we're going to need a username and a password. Now, the username, one of the cool things about Astra is that it lets you do kind of granular permissions based on authentication tokens. That's pretty slick. And so, like, I'm going to select my role that I care about. In this case, I'm just going to get a database administrator to keep things simple. And so when I create that, and by the way, like, these secrets details are only going to be created and showing up once, and like you got to save that CSV somewhere safe. You won't be able to get it again. But yeah, so these are what I can use to connect. And if I grab this token and I use the username token and the password, that value, then this is enough for me to connect to Cassandra. So just these three things are going to establish my Cassandra connection. And we talked about how you want to instantiate your session by just copying this one single injection line of code. So let's just grab it, throw it right into our class here.
Oh, can you blow up your code a little bit, Seb?
Absolutely.
Don't actually blow it up.
All right, is that big?
That works. I think, yeah, that's readable.
Right?
It's more readable.
As in, don't explode.
Import and import. Right on. So we've got ourselves a session, and so at this point, we should be connected to Cassandra. I'm going to go ahead and do what Eric had suggested, which is to add the metrics and health stuff, so we can show that off. So let's add. I want to enable metrics and health here. And all this stuff is getting picked up on the fly. So if I go back to this health UI thing, let's see if it actually finds any probes. Oh, check it out. So yeah, I'm connected to Cassandra, and it tells me I'm in US East, right? That's pretty great.
That's cool.
Yeah, so we've got a connection established to your database you just created on the cloud, right? This took us all of, I mean, if it takes me like 2 minutes to deploy the database, 2 minutes to, generate this Quarkus thing, and then like another 5 minutes, because I'm not that smart, to like set up all the config, like we've got ourselves, a Java application using Quarkus connected to Astra on the cloud for free in under 10 minutes. Pretty cool stuff. This number of node things is actually interesting. We're using a serverless database, so there is no concept of number of nodes. I think we need to update some APIs of the driver. I mean, the driver expects nodes, right? So I guess it has to show something. But yeah, at the end of the day, what it's telling us here is that we're connected, and that's great. In case you don't believe it, let's go actually read some data from the database. So we're going to create a new method here, public.
So one thing to show, if you could just expand your imports for a second. So,
oh yeah.
So you notice that there's nothing related to Quarkus here. I mean, this is all standard JAX-RS and CDI, context dependency injection stuff. There's nothing specific to Quarkus in here.
Yeah, it feels like I'm just coding Java, right?
Yep.
But my dev experience is so much nicer. Public string, get Cassandra data. We're going to do, so at this point, I've got the session thing, right? And so I can say this.session from any, session from anywhere. And if anybody on the call here has used the DataStax driver, you're familiar with the session object in the Cassandra DataStax driver. And I could go ahead and just execute a statement. And in this case, I'm just going to go ahead and select star from system local. Right, that's something you're familiar with doing. This is going to give me back a result set, which we can, what is this thing called? Get, there's like a nice one gives me the first row in that result set, and then this get formatted contents is like a nice string representation of that row, that first row, and I can just return that. So if I go, and then I should tell it, all right, this is a get. It produces a media type, and we're going to call this thing test. So if I save my class, now I've got a /API/test endpoint that I've created that is going to go run that Cassandra query. So let's do it. And if everything is well, we should actually get some data back. And it's waiting. What's it waiting for?
You know, I know what it's waiting for.
Oh, it blew up. Did I mess something up?
So it's waiting because remember we talked about this REST Easy Reactive versus REST Easy Classic. So you're doing blocking work on the IO thread here. So the app is like hosed while you're doing that. So you need to tell REST Easy that, hey, I'm doing stuff, move my work over to a separate thread here. At least that's what I think your problem is. It's definitely it's a problem.
One of the potential multiple problems.
Yeah.
Let's see. All right. The live demo gods.
What happened?
Has been blocked. Yeah, so that sounds right. And yeah, so to remove the blocking problem, you add the blocking annotation, and then Quarkus should be smart enough to get me off that IO thread.
Yep.
We think. So now what's wrong with it? Still blocked. Maybe it's.
Is it still? Nah, kill it and start it over.
Yeah, we might have to just because Seth did something dumb. All right, let's kill it.
Oh, is this where? Do we need the bucket? Do you have the Tears bucket?
Yeah, I was hoping that we were going to get through this whole thing without killing and restarting Quarkus Dev, but yeah, I guess there are some dumb things that you can't protect us against.
Yes, we talked about this, right? You know, user error.
Bug lives between keyboard and.
I had one time I was speaking at a conference. Oh, there you go.
Yeah, we're in business. That's pretty cool.
One time I was speaking at a conference and I had an attendee ask, if Cassandra is so robust and resilient, why do you need backups? And my answer was, it's not because of the database. It's because if someone truncates or drops something that you shouldn't have truncated or dropped or whatever, that way you...
Definitely worked with folks that, hey, I've got 3 replicas, so I've got 2 backups. And that's how they ran production. Maybe not the best play, but I've definitely encountered that in my time running Cassandra. Okay, so cool. We're able to get some data from the database in a blocking method. So now we're almost at the part where we can start filling in, stubbing out this app. How are we doing time-wise, by the way?
Oh, we're good.
Got over
half. Yeah, we've got another 40 minutes. So I think
that sounds
good.
Perfect.
Yep.
Okay, great. So the next thing, Eric, is we're going to do some fancy Quarkus stuff to actually do something on startup, right? Which is create the table. So to do that, I think we said we were going to do a public void method that is subscribed to the startup event, right?
Yep.
And so that takes an annotation that I forget, but I'm sure you remember. Start something.
Observes.
Yeah,
so there are lots of different events that Quarkus emits like during the different life cycle of the application, startup, shutdown, pre-start, all that kind of stuff. And when you want to, anywhere in your application, if you need to do something on one of those events, you just create a method and tag it that says, hey, I want to observe that event.
So let's test that. The app started. Now, this slick, live reloading thing, quote unquote, like technically restarts Quarkus when I hit an endpoint and something major has changed, right? So if
when you do something that it thinks it needs to restart. So if you do nothing, it doesn't need to do anything.
And so I added a non-startup observe, so I think it thinks that I need to, maybe not. Let's see.
It would be up above the startup stuff. Yep, there you go.
The app started, pretty slick, right? So that watching the event reactive thing work, that's pretty cool. And so at this point, what I really want to do is create myself a table. We're just going to execute. We're going to do a create table statement here. That's going to be a...
Probably want to spell create right?
Yeah.
I like crate tables.
Crate tables.
Crate those tables.
All right, let's refactor that puppy.
Oh, that's great. By the way, I just want to point out, Rajagopal and Prathamesh, we do see your questions. I'm waiting for a point where we get to a good spot with the code that Seb and Eric are working to kind of respond to some of those questions because they're a little bit longer form, and I think we'll need a little bit of input from Eric and Seb on them as well.
Right on. That sounds great. So let me get this startup table creation thingy, and then we'll take a couple questions, and then we'll move on to more endpoints. We'll move on to actual endpoints. If I go to my SQL console, we're going to go ahead and like use the nice autocomplete in SQL.sh to craft that create table statement. And so it knows that I have a to-do key space, and we're going to give the table, what should we call it? To-do items?
What goes with
to-do.
Crates?
We're going to call it to-do.
To-do.
And this thing is going to have a list ID, which is an identifier for like the actual list of to-dos itself. That's going to be a text, and we're going to have an ID that's just the identifier for the item itself. We're going to have a thing called completed, which is going to be a Boolean, and that's going to be whether or not the to-do list item has been done or not. And I'm going to have a thing called title that is text. And again, so this is when we're going to get into some Cassandra data modeling. My table needs a primary key. So for folks that are, coming from RDBMS, which I think is all of us at some point, a primary key is the thing that we use for uniqueness in our database, right? So if I've got some keys in my primary key, that's going to represent what's unique for a row. And so I definitely need a list ID and a regular ID and the item ID, because I want separate rows for each. Now, notice that in Cassandra, the first thing in your primary key is the partition key, which is the thing that we talked about for how you determine what nodes own what data. And so the list ID is the first thing in my primary key, and I can optionally throw that in parentheses so that I can do things like, potentially use a secondary key here, multiple keys to determine my partitioning. Okay, so we're just going to keep this data model simple, and it's just going to look something like this. So I'm going to copy that over and throw it in our string here. All right, and one thing I want to do is we said we were going to use string format, didn't we?
Yeah, it doesn't matter.
We're going to
You want to add back though that if not exists, otherwise you could run into problems.
Thank you. If not exists. So if we were running like regular Cassandra exists, I might tell people not to do this thing that I'm doing here, which is dynamically generating DDL like on startup for the app. Especially if this is a multi-process distributed app, you're going to have lots of these coming up at the same time, and because you would get into some gnarly race conditions for DDL if you were doing this. What do I want here? %s?
Yep.
So, but in Astra, we do linearize DDL in Astra serverless, and so that gets you basically so then this isn't going to be a problem on the cloud. If you were doing this in your own Cassandra that you're managing, you should probably just maintain your state manually, either with a DBA or whatever. So in this case, we're going to pass a key space name and a table name as the two arguments to this. To this string.format command. So this is going to be, we said to-do.to-do, right? So we said something like that. All right, so we've got a create table statement. Let me try to make this a little bit more legible since we're falling off my screen. All right, you can at least read it. The spacing isn't pretty, but we're live. We don't have infinite time here. So okay, so there's our create table statement, and we will execute it on startup. And once we do that, we're going to say, I created my table. Lovely. So so now if I hit again like a random endpoint, the test one that we had from before, hopefully Quarkus thought that I needed to start over, and it did, and then I should see table created, which means that if I go back to my database up here in my web UI, I can select star from, let's see if it exists, to do, and it's empty, but it's there. So we've got ourselves a table, and now we're ready to like actually read from that table, stub out some of the endpoints. Well, maybe this is a good time for those questions, David.
Okay, yeah. So let's see. So let me scroll up and find it here. Here we go. So from Rajagopal says, I have this demo application deployed on two different data centers, and each connect to its own database. In this scenario, how would load balancing work and also the mirroring? Now, I had a follow-up question for him because I was like, that sounds like multiple data centers in the same cluster from the Cassandra level, but I'm not sure if I was missing something that he was referring to from the actual Quarkus application piece.
Well, that's an excellent question. It's an excellent question, and it sounds like he is talking about data centers in the Cassandra sense of the word, but maybe both, right? Like, so if I pull up this picture, we've got 3 physical locations in this picture.
He did clarify further on. He's like, if the app is running in more than one data center, how would the load balancing be handled here? In other words, are we dependent on Kubernetes here? So
yeah, Kubernetes is like has its own challenges with geo distribution.
Yeah.
But let's take maybe Kubernetes out of it, and then maybe we
focus
can
on
bring
the first part. Yeah.
So there's enough here. So you've got 3 regions that Cassandra is spanning, with 1 cluster, 3 data centers, spanning these regions. Now, similarly, across the same geographic deployment, you're going to have an application tier, right? In this case, let's call it Quarkus application, and that has potentially multiple instances of this app running in all 3 of these data centers as well. Right now, each of those applications probably is connected to the local data center because you want those geolocal latencies, right? Like, no good reason to talk to Europe from the US if you don't have to. And incur those 100 millis of every time you do a put or a get. Right. So I think one of the question was mirroring. When you do a write to the Cassandra database in the US, as long as you've got your replication set up properly, that write will get replicated not only to the multiple replicas inside the US here, but also to multiple replicas in your other data centers across the globe. The database takes care of that automatically. And so, if you did that right, and then a little bit later, you did a read from the app tier that's sitting on top of your data center in Europe, you would still be able to, pull that data. The latencies to actually get things replicated are very fast. I mean, this is something that like folks have been doing for years and years. I mean, there was like I think there was a blog post, like this must be like a 6-7-year-old blog post by now, that Netflix did, where they write a million things in US East and they read it immediately from US West, and it's all there, right?
Yeah.
And so this is something that people do with Cassandra basically all the time. So that's pretty standard. Around the mirroring, the thing that's a little bit, I guess, trickier is like what happens with the load balancing, right? So you need to have like a way of routing the request from your users in the US to the application tier in the US, right? And the users in Europe to the application tier in Europe. And that's like routing that, is going to be potentially specific to your own architecture, right? And some folks use kind of global load balancers. There is some like interesting technology out there, like that the cloud providers provide around this. There's also some third-party tools around, global load balancers based on geography that will take, requests coming from the internet, from different regions around the world, and determine, where to route them to your backend apps. So hopefully that answers the question. If we wanted to get the Kubernetes part of that into this, like Kubernetes isn't really super mature in terms of running in multiple regions. There is Kubernetes like multi-region. I think it's called some sort of federation coming, like being worked on, I would say. But currently, what people do is they just run separate clusters, separate Kubernetes clusters across the regions, right? And actually, that's what we do in Astra when we have multiple region deployments. There's multiple Kubernetes clusters that are running, and then we just have to figure out networking between the two. So hopefully that answers.
That's an important distinction, is that if you're using Astra, where it's built on Kubernetes, and you don't need to deal with that, right? You're not like, we've dealt with it for you.
That's right.
Yes, absolutely. So like, for example, there was a tweet, so we tweeted when an Astra serverless came out. I forget who it was. Maybe so Jim McCollum, our VP of engineering, had a nice blog post, and somebody tweeted that. And I think it was Kelsey Hightower. You guys probably know who he is from Kubernetes fame. The guy's awesome. He tweeted, "Hey, how is this serverless if it's all built on Kubernetes, right? Like what's going on?" Well, the service itself is a serverless service. Like if you're a user, you just saw me do a couple clicks in our UI and get a database and an endpoint that you can use in a serverless fashion. You get billed per operation, that sort of thing. Now, the service itself that the DataStax is running, that thing is built on Kubernetes. And so it's kind of a cloud native, Kubernetes powered, supercharged Cassandra. So under the hood.
Sorry, Seb. I think it speaks to the fact that serverless on the function side is an arbitrary code execution platform, right? Like that's a container for code, whereas a data service, like a data API, a public data API, like we're offering, that is not an arbitrary code execution platform. That's kind of like pipe in, get out, right? The fact that it's serverless underneath the covers is just what gives us a more efficient, implementation and billing model for use. And right, I mean, there's a big difference.
Absolutely. So serverless not as in function as a service, but as in build more, own less.
Exactly.
Okay. So go ahead, Seb. Sorry. Go ahead.
I was going to ask if there were other questions.
Yes. Okay. Good. So then Prathamesh had asked, how does Quarkus SQL session handle load? Do default configuration sufficient to connect multiple nodes of Cassandra, or any specific configuration required? Where to change config if required? I could handle that for a normal SQL session. I just don't know about the Quarkus one. Is it essentially the same?
Sorry, you're saying if there's configuration changes for the Cassandra driver?
Well, yeah, I think what I interpreted from that question was, really, is there any difference between the Quarkus SQL session and regular SQL session and how the driver is handling load balancing, anything like that? No,
it's the same thing.
Okay.
So it's the same thing. It's just like we're just doing the boilerplate of establishing that connection and standing up that cluster object, and it uses the native Quarkus config, which is just the thing you put in application.properties. But aside from that, you're literally using the DataStax Cassandra driver. I actually just realized I didn't finish the Kelsey Hightower story. So somebody on Twitter explained, the service is serverless, but the way that they run it themselves is Kubernetes, and he's like, oh, that's dope. And so I think everybody at DataStax got really excited that Kelsey said that our stuff.
Yeah, that's right.
Right. So that was super awesome.
So I have one other here. I was having a conversation with somebody in Discord with Nixak, and we were talking about Astra, right? And he asks, so does Astra act as a load balancer too? So here's just something I just want to kind of point out. Cassandra itself, right, by its distributed nature, its peer-to-peer and leaderless nature, and the way that it handles requests is already load balancing for you, right? Seb talked about it a little bit earlier, but the fact that you have multiple replicas that have data that lends itself naturally to be able to have multiple replicas that can service a request for any particular data, instead of just one node over and over. And that is stuff that is managed via the driver, via Cassandra itself. So Astra does that naturally just because it's built on Cassandra. Right. So all that part is actually being done from a load balancing perspective. That's being done underneath the hood. It's just part of how Cassandra works.
Yeah. So strictly load balancing, the driver does it. And then if you're talking about inside of Cassandra, routing stuff, we just call that coordinating. But I guess you could say that it's Yeah. So like routing the operations inside of the Cassandra cluster is what we call coordinating. If you talk to a Cassandra person and they say coordinating, that's what that means. But yeah, so there is load balancing at the driver. And so the driver's basically aware of all the nodes in the cluster. It's actually established connections to all the nodes in the cluster.
Yeah.
And it kind of knows who owns what. And it's like smart enough to spread out the load and route things intelligently based on your config, right? So like it knows what data center to hit and things like that. Okay, so let's come back to coding. I think we were at a good spot where we can actually go back to that little app that we had, and we had this request that failed, and it was a GET request against this endpoint, giving us a 404. So we're hypothesizing at this point, right? Because we're kind of reverse engineering this app. Like if you're doing a GET against API/to-do/an ID, it sounds like you're trying to just read the contents of the table that we created, right? Like basically get the list of IDs, the list of to-dos for this to-do list. So we're going to go ahead and try to implement that. Let's see. So I'll build myself a fresh endpoint, which is going to say public string get to-dos, and it's going to have a path, and that path is going to be, so API is already in there, /to-do/ what should we call this? List ID maybe?
Yeah, I think so.
List ID. So that's a path parameter, and so I can say at path param, just our regular Java XRS list ID, and so this is going to be a string called list ID. I could call it ID, I guess, like this, but doesn't matter. And yeah, and then we're going to again grab our session, and we're going to do execute, and we're going to grab a insert. I don't know how to tell Skype to not do that, but it's fine. Select statement. Select our to-dos, and I'll go ahead and create my constant up top like we did before. Constant field, and this is just going to be a select star from dot s key space and table. Now I do have to create these in order. All right, right on. So that's a select statement. Actually, I think we said, I don't think this needs to return anything. I can return void. And
No, you got to return stuff. It's expecting to get the to-dos, right? You got to return something.
Oh, you're right. I do need to return something.
So what do you think?
Let's return a string for now because we don't know what the heck it actually wants. But yeah, you're right. Like it probably needs the whole thing, right? It probably needs a JSON representation of the to-do lists. Yeah,
a bunch of items or something that it's going to return.
Yeah, that makes sense. But for now, I'm going to get the same. I'm just going to return the first row in our payload just to test stuff out.
You need a few annotations there too.
Definitely. So we need to say it's blocking. We need to say that it's producing some, let's say application JSON at this point. And we need to know that it's consuming.
No, it's not consuming anything.
Oh, it's not consuming anything. That's right.
It's a get. It's a get though.
Get. All right.
Seb and I could go on for hours talking about REST semantics, but that's outside the scope of this, right?
That's right. That's right. Yeah. Yeah. Eric was saying he didn't like how the app was set up on the front end, and I didn't. So let's see if this thing even works. I refresh my page, and hopefully it's going to try to hit an endpoint. It didn't get a 400, it got a 500, which means Seb screwed up. 400 means UI screwed up. 500 means
you got a null pointer
up in the back end. A null
There's
pointer.
no entries.
There is no entry, of course, because we have an empty table. So let's just do a simple. So this is where we got into like, should we do this with optionals, right? So we can if we want to.
So it's just a time check. We're under 15 minutes.
Yep.
Let's keep this rolling. So I'm just gonna do a quick null check. RS dot 1 equals null. So it does not equal null. Else return nothing. Keep this moving. Does not equal. So no 500. Hopefully. Lovely. All right. So yeah, it did. It went out and it tried to get some to-dos, and it got a nothing payload. Really, we should like flesh this out, but in order for us to go like figure out the POJO and what things look like when we read them, I kind of want to just like insert something first, because we're being hacky. So I'm gonna put in the Erick vacation to do.
I need a vacation so bad.
I'm taking a vacation. I'm off starting tomorrow, folks.
So am I.
Great. Oh, really? Yeah.
So,
right
so let me guess. So that means you guys have this whole thing. You stir up a whole bunch of questions and then you take off.
Right.
So if you guys have questions next week, just hit Erick on Twitter. Oh boy. All right. So yeah, there's a request. It tried to do a post, which is creating a to-do item, and here's the path that it used. Awesome. And then you can see that there is a payload associated, and that payload is just a JSON representation of a to-do list item that's got a completed, an ID, and a title. So I think it's time for us to make that POJO. Let's stub out our create to-do item. This is also going to take a path param. Did it? Yeah, it did. But it also took consumes media type application JSON. I do need to import that. This is going to be a post. Post. It's going to be blocking. And it's going to have a path, which is actually the same path as the last one, right? To do, and also a list ID. But now, differently, we're also going to take a to do item called item. All right, and for this, let's create an inner class. We're going to keep everything in one file for this. So we said this probably wants to be public, static. So if you want to set up ID debugging, maybe this can be fun. I'm going to do that right here. Show folks how to add a configuration. So one cool thing about Quark is, again, like this is all running in my terminal, but you can see when it comes up, it makes reference to port 5050 for remote debugging. It's automatically configured that way. And so that makes it so that I can do kind of the dumbest and simplest remote debugging configuration in Java. If I type in remote, Gosh. Where's like the simple remote one here? That's it. This is all I need. I apply, I run it, and then you can see that I've connected to the target VM on 5005. So if I go and try to get a vacation, hopefully, let's see if I'm not missing something, we should actually get the, yeah, we should actually get this to stop. What did I do wrong? I got a 500 error.
All right, Seb, you've got 4 minutes to make it work. No pressure. No pressure.
Oh, geez. This is taking longer than I thought it was going to take.
Yeah, because we got to give away swag. We've got all these folks who have stayed with us, and we
Yeah.
didn't scare them away or whatnot.
Well, maybe what we do is we take a swag break, and I'll keep figuring this out.
We could do that.
That's a great idea.
I think at this point, everybody who's been with us so far, they deserve their swag. They totally deserve their swag. All right, so with that, now it doesn't mean you can just leave. We got to watch more tiers with Seb. But all right, so
these are not happy tiers.
Yeah. So the first thing I'm going to do is I'm going to drop. Now this is time based, right? So this is for the Red Hat swag. First 100 people who want it are going to get it. Everybody else, sorry, you're not going to. So I'm going to go ahead and I'm going to put Red Hat. I'm going to try to make this as fast or fair as I can.
It's actually Quarkus swag. There's some actually pretty good stuff in there that you get.
Oh,
to
my
pick.
bad. It's Quarkus swag. It was a Red Hat link.
It's Quarkus swag, but it's only the first 100 people.
All right, so I'm gonna hit it in both YouTube and Discord at the same time. So bloop and bloop. There's the Red Hat swag. Go to that form. You got to fill that out to get yourself some of that. And you get to pick the swag too. That's one. When we give swag, we just give you the swag we give you. You actually get to pick the swag here. So we'll let everybody do that for a moment. While Seb collects his tears.
Hey, things are working. All right.
Oh, a U.S. address only. Oh, okay. Well, here I got a different thing for you.
Yeah, unfortunately, we can only do shipments. We can only drop ship to U.S. addresses.
I see. Sorry for our non-U.S. folks. I didn't realize that part. That's okay. I'm gonna have another giveaway for you.
Yeah, sorry about that.
Okay, so I'm now going to drop the, you could argue that this next one will be awesome as well. Now this one's not time-based. But the form I just dropped, you'll see that thanks for, oh, hello there from Poland. Hi. You'll see that the link that I just dropped, your giveaway. So that form will allow you to get either your voucher for 2 attempts for your Cassandra certification. So there's a couple different certifications, actually. You can choose to use it for any of them. And you can get 2 free attempts. Those are $145 a piece. So it also helps in a case that maybe you don't pass the first time. Well, guess what? You have a free attempt. The other option is to just get $300 in Astra credits. Now, given that the $25 credit that we give you just by default every month, that rolls every month, is enough to actually run small production workloads, $300 actually gets you pretty far, right? If you start really using it past that $25. So you choose, right? And the instructions on how to get either are there. With the case of the $300 credit, you just have to give the DB ID of one of your Astra databases. But go ahead and fill those out so you can get some stuff. And that's a thank you to all of you for coming and being with us today. I think, Seb, you said you made some progress in that couple of minutes there?
Yeah, we're doing well.
All right.
We're ripping here. So I can catch you guys up. I started creating my Pojo here, and I created a insert item, a query. So let's populate my Pojo. The Pojo is going to have a, let's call this private string ID. It's going to have a list ID, or actually it doesn't have to have a list ID. It has a completed title and a Boolean completed. And then I can get IDEA to generate some stuff for me. I'd like some getters and setters, please. I would also like
2 constructors.
a
We
couple
learned
of
this the hard
constructors.
way.
Yeah, we said, hey, you don't need the no argument constructor, but then you do need the no argument constructor for serialization, deserialization, because that's what Jackson wants.
Well, it's only because
So-
it's an inner class. If it wasn't an inner class, I don't think it would need it.
Yeah, so we'll make Jackson happy for the inner class. Right on. Yeah, some of these gotchas. This is why we try stuff before the day of, right? Throw this thing up on top just for aesthetics. And so at this point, I've got a Pojo. I'm going back to my create to do thingy, and there we go. We're gonna grab the, what order is this in? ID, title, completed. Well, okay, first I have the list ID. Oh, sorry, I mean the order from the insert statement, which is ID, text, and completed. So we're gonna grab item.id. These are positional item dot there is a way to do this by name, by the way, but text and item. It's going to be .id. So get ID. These are private. Get title. We said. This is the text. This is title. And then completed. Get completed. Why isn't that here? Is completed because it's a Boolean. Lovely. All right. So this should actually create the item. And in theory, I should actually return.
I thought we
Let's
said that
return-
this was void. It didn't return anything,
Let's make it void.
which is why I said it should be a put, not a post. But
Right.
now we're
Yeah,
getting into
that-
semantics.
We had that whole argument about proper restfulness.
Yep.
Um,
I tend
on,
to
so-
fall on the purest side of the REST spectrum.
Oh, the other thing that I had going is, by the way, folks, like I did get my debugger to stop here, and you can see that I had an item. Now the item had nothing in it because I hadn't instantiated it yet. But if I let this thing rip and run it again and try to insert something, well, let's see, where's my breakpoint? I may have gotten rid of the breakpoint. But anyway, let's see what it did. So 500 for what? For the post. That did something stupid. Let's see. What am I missing? I can't write SQL queries. Insert into.
Oh.
I forgot to bring our format past my table name and key space. All right, key space name, table name. Try that again. So this worked. It's the post, and I got an error now on my get. So yeah, we did a post. Let's see if that actually shows up on the database. There you go. We got data in the database. So we have written to Cassandra with 1 minute to spare, folks. Right on. Fire. That's good. We can keep going, but I think let's see. I'll keep working on this, but I don't know if I'm going to get cut off or not. What's the deal, David?
Yeah, we do need to probably do it pretty soon. No hooks are gonna come from the side of the screen.
David's got a big hook that he's ready to yank across the screen here.
Are people throwing tomatoes yet?
No, I don't see any tomatoes. If anyone wants to throw a tomato, go for it. But yeah, we should tally it up here real quick.
Yeah. Okay. So here we go. The return
Shepherd's Pole Chrome extension.
That's right. Yeah.
it's done. All right. So this is as far as we got, I believe, folks. Yeah.
Hey, Seb, do you want to touch on real quick? Someone in the chat is saying, why do I have to write old school insert and select queries, and is comparing it to like Spring Data? Why would I use Quarkus if I have to do that?
Oh, you don't. You don't. So
Yeah.
you can work with the driver however way you want to work with the driver.
Yep.
So the driver supports select queries, and obviously like this is a pain point because I'm making mistakes typing them out. You can use the object mapper. The object mapper is what gets you away from having to write, insert statements like we're in 1995. So.
By the way, Jin just threw a couple tomatoes and a kiwi at you.
Thank you, Jim.
Yeah, you can totally use the mapper and all that. There's no limitation there. I don't know about you, Seb, but I find it, especially when I'm doing things where we're not talking about the mapper explicitly, I will write out like you are in workshops just like this, so everybody can follow along and it's really easy to understand what's going on, kind of deal. But yeah, you're not limited. It's not a Quarkus thing, and you're not limited anyway.
Yeah, I just dropped the link to the mapper docs, but yeah, that's a good point, because then it's like, oh, auto mapping magic. Like, wait, what happened there? And this way that's a really good point.
Exactly.
Yeah, I think you're like everybody understands what an insert statement is, and so sometimes when we take it back to that for the live demo, like points get across.
I should point out real quick before we wrap up here. Apple Pie is saying. Oh, go ahead, Peter. Sorry.
We do have the recording posted to the DataStax developers channel.
That's right.
On YouTube. But you have to give us some apple pie if you want the recording.
All right, folks.
Let me drop that URL for DataStax Dev's channel on YouTube. And folks, we do these workshops pretty frequently. So if you wanted to hit that magic little subscribe button, you'll get notifications about other workshop recordings that the developer relations team here does at DataStax. The channel is I just dropped the URL to the channel in the chat.
Awesome.
For those of you curious, the answers are here, so you guys can.
Yeah, and the repo, we could drop the repo one more time just for those who are interested. If you go to the main branch, there you go, boom, and I'll do this. If you take a look at that in the main branch, it's all there, right? You can just go ahead and build it. Then you can go back to the puzzle branch and try to puzzle out like you saw Seb do. All right, well, with that, thank you.
Try using the mapper.
Yeah, and then try using the mapper, exactly. There should be no limitation there. So thank you, everybody, for joining us today. Thank you, Eric. Thank you, Seb. Thank you, Peter. Every time I say that, I feel like we're doing the romper room. And if anyone gets that reference, then reach out to me and let me know. But again, thank you, everybody, for joining us on this workshop. And we'll see you again next time. Take care.
Take care, friends.